So I'm really delighted to welcome Dr. Victoria Nockles, who's going to chair this panel. I've named this Space Junk as a layman. I'm really excited. I have to admit, I know absolutely nothing about the session, but I will be copiously taking notes, and I'm excited to find out what's going on up there in space. Thank you.
Thank you. So on the panel with me today, I also have Elliot Thornton, who's a space resilience manager from the UKSA. James Parr, who's CEO of Trillium Technologies and director at FDL.ai. Colonel Shaun, who's the Deputy Head of Capability and Force Development at UK Space Command. And Alex Agathanggelou, who's the Senior Space Scientist at DSTL. And Jamie Wickham-Eade, who's Head of UK National Future Programmes, Airbus Defence and Space UK. So space is a critical part of our national infrastructure, and we're increasingly becoming reliant upon space. Satellite systems are crucial for position, navigation, timing, and communications, and situational awareness. We're seeing rapid escalation in the number of satellite launches, which is increasing the risk of in-orbit collisions. So I'm going to quickly note that in the MOD, we love our acronyms. So each of us is going to sort of use an acronym to describe their work. So, Elliot.
Our directorate's gone through a bit of a change, so my one would be EO, LEO, PNT, SSR, MOSWOC, NSPOC team.
And if you could quickly explain what that means.
I'll explain the S&R bit. We're the security and resilience team, so that's fundamental to my work.
Over to James.
Well, I was trying to think of an acronym for I got the sofa, but yeah, our TRL, which probably most people know, which is Technology Readiness Level.
Shaun.
So I'd probably go with force design, which is what it is I have to do within UK Space Command. So force design is about understanding what we need now, what we need in the future, and then trying to stitch it all together through a coherent enterprise architecture.
Alex.
So I'd have to go with the acronym that describes my entire field of work, which is SDA, Space Domain Awareness, which is all about basically understanding what's going on in the space environment, be it natural space environment phenomena and man-made objects, debris, operational satellites, that kind of thing.
Jamie?
I think mine would have to be TCPED, so tasking, collection, processing, exploitation, and dissemination.
Mine would be RF, so radio frequency. So what do we think are the major challenges and threats to ensuring a safe and sustainable space environment? Feel free to jump in.
Should I kick us off? So, I mean, obviously, space debris and orbital congestion. There's an ever-increasing number of satellites being launched in mega constellations. The more satellites you've got up there, the more higher risk you've got of collisions. More debris, the worse it could be. Certainly one of them.
So I'd chip in with something that we've been monitoring for some time, space weather. It's one that often gets forgotten about or not thought through properly. But it's absolutely vital to be able to understand what it is that's coming at you through space if you're to be able to operate in it effectively.
I think jumping off the back of what you mentioned about space debris and just the number of satellites operating on orbit, there are nearly 40,000 tracked objects in orbit, and those are just the ones that are big enough to track with radar, with telescopes, that kind of thing. One of the biggest challenges faced by people trying to do space domain awareness and understanding what's going on in orbit is that data overload. So with more and more commercial and sovereign space tracking capabilities, telescope networks, radar networks, that sort of thing, there is an ever-increasing volume of data being pumped out by these sensors every day tracking these objects. And it becomes very difficult for human operators to be able to get through all of that in a kind of efficient manner to be able to understand what's going on and ensure that satellites and other objects that we put on orbit are operating safely. So it's both a challenge and I think also an opportunity for AI, machine learning tools to kind of take on that challenge and really help with the processing of that massive volume of data.
What are the up-and-coming capabilities on the AI side that can really help operators in tackling this challenge of having large volumes of data that we're unable to analyse quickly?
I mean, I think it's moving really quickly, and AI, as we've heard before, is really good at solving or taking on complex things. But building on the space weather example, AI is extremely powerful at replicating physical systems and doing it very efficiently. So things that used to require a supercomputer, you can now do in a few GPUs. And so, for example, you could start to simulate the thermosphere, understand how the relationship between the sun and the thermosphere is affected by solar activity. This has a massive implication on drag for spacecraft. And so that's an example of using AI to simulate a complex physical system. And those opportunities are huge. There's everything from, as we say, space weather, but also the trade space analysis of spacecraft. These 30,000 objects, or you said 40,000 objects that are being tracked. AI is particularly powerful for starting to understand all those micro decisions those spacecraft might be making and the implication for potential collisions. So yeah, there's lots of opportunities.
So you have a lot of historical knowledge around the physics behind space processes. How do we kind of best incorporate modern AI capability with physics aspects to ensure that we maintain a really safe space environment?
I mean, data is the key thing. So having extremely high-quality data sources, that's the starting point. So we're lucky with the sun in particular because there's lots of instruments that have been put up with a lot of foresight. For example, the Solar Dynamics Observatory, another acronym, SDO, which looks at the sun every 8 seconds in 4K. It's a phenomenal asset, but that really helps us understand what the sun's doing. And then you can build this new category of AI called a foundation model. The foundation model can ingest this petabytes of data come from SDO and then start to turn this into predictions which are useful downstream for satellite operators. So that's, again, an example of like a complex physical system which is now being, if you like, packaged by AI to turn that into insight that people can use to make better decisions.
So that raises questions around data access, which can be a big challenge, ensuring that we develop algorithms that are reliable and trustworthy. Alex, do you want to kind of comment on where we see the major challenges and how the UK can help with that?
So there's a big challenge in terms of both data, getting access to data and being able to share it effectively with people who want to do this fantastic work with developing models and tools, etc. So I think investment and development of that data infrastructure is vital in order to be able to meet these challenges. There's an ever-growing number of commercial space surveillance and tracking companies that are providing optical and radar data for objects in LEO and beyond. So the data is out there. We just need to be able to ingest it and actually make good use of it, which Shaun might be able to comment a bit more about this, but there have been some investments on the kind of government side looking to develop that infrastructure.
Yeah, no, you're absolutely right. And, just to your first point there, it's, from a sort of principal perspective, it's really important that you own your data, because then you can choose who it is that you want to share it with. And so that's really important for us. And to your point in terms of where have we been investing, one program that was recently announced is Borealis. Borealis will provision the software going forward for space domain awareness within the National Space Operations Centre. So that'll be an iterative program that's running for a number of years that will really seek to bring the best that is out there in terms of the work that you all do in terms of developing algorithms and solutions and pull those through and into defence. So we're really excited about Borealis. I think it's going to be a really interesting program over the next few years.
Perhaps as well, Jamie, you can talk a little around the Oberon project that it was recently announced that had been awarded to Airbus.
Yeah, sure. So, recently we were fortunate enough to be awarded the Oberon mission. Now, Oberon is a 2-satellite synthetic aperture radar, so another acronym, SAR, there for you, for UK Space Command. It's very exciting because it's another step on the UK kind of own access of satellite ISR data, intelligence, surveillance and reconnaissance, another acronym there. But equally, it is a great platform to show really what UK and UK industry can provide in terms of like the global kind of space picture. So it's a great capability.
Are there concerns around how congested and contested the space environment is becoming and the implications for the safety of future missions and future programs?
Yeah, I think there's growing concern kind of not just related to Oberon, but just generally just as a space operator. There is a multitude of like ways that AI can be used to help operators, such as AI decision-making for conjunction analysis to avoid that. You can also use AI to help determine how you want to use your propellant in your space mission to make avoidance maneuvers. But equally, what's very important in terms of space sustainability is actually these sustainability requirements are introduced early into the design phase of the mission. If you're not designing robust, resilient, secure satellites, then when you need them to move, they might not be able to move. So we're kind of using AI to determine whether we can do AI-assisted fault detection and analysis and stuff like that for operators to avoid as little downtime as possible in order to keep the satellite going. So one, it can be doing its job in the operational, but two, if it is required to move, it can move.
You raised an important point around sustainability there. James, do you want to sort of come in on some of the challenges around sustainability within the space?
Yeah, that was interesting because you sort of talked about two connected space sustainability problems. Should we just say SSA? But when you have a space weather event and you might not know exactly where your spacecraft is, and then, of course, you've got lots of extremely complicated trade space, and you need to make decisions on where to put that spacecraft and what decision to make. And I think we're heading towards a situation where there might be millions or billions of decisions that need to be made every hour, certainly every day or so. So how do we do that? And you can sort of see how sooner rather than later we need to put the intelligence on the spacecraft, because that spacecraft's going to need to say, well, listen, I've got this much fuel. This is my task at the moment. This is where I think I am. And then communicate to another spacecraft. And so that kind of bubble of uncertainty around each spacecraft can be negotiated very rapidly. And so this is all great opportunity, I think, and certainly something which potentially the UK is extremely well positioned to contribute to, because we're really good at that sort of stuff here. We're really good at clever small sat designs and the sort of infrastructure that might go inside those sorts of spacecraft. I guess the question I would have is how do we get the timing right? Because this is always the difficult thing. The talent is here, but the moment to actually invest in this so that the rest of the world can start to use these sorts of capabilities, this is the big question.
Where do we think we should be investing our money most in that domain?
Well, I think foundation models probably, because these are tools that everybody can use. So we were chatting just before about if you have a system like Oberon, it's 2 SAR satellites, but there are more SAR satellites. And wouldn't it be great if you had all of those, all that data in one place from all the different providers? And if it was a foundation model, that means you could imagine that downstream applications could access that set of embeddings, and everyone benefits. And so there's definitely a role for public entities to build these foundation models for everybody to use and make them validated, well understood, maintained. So everybody can benefit from these investments. So that would be my answer, but I'm sure other people will go.
So just probably coming out a level actually. So when the Defence Space Strategy was written, we talked about a framework for thinking about capability, and we described 3 things. We talked about own, collaborate, and access. So own are those capabilities, a bit like you were describing earlier in terms of Oberon and Borealis, those things that must be nationally owned and nationally operated. But then as you start to sort of move into collaboration, that can be largely collaboration with your allies and partners. We are still a relatively small nation, and so the amount of space-based services and data that is going to be collected from space, we've got some really key reliance on our international partners, and we would wish them to share data with us, but also we would wish to share our data back with them. So creating great relationships there, and then you've got the bit around access, because the pace of technology here is pretty quick, and we realise that. You're not going to be able to build everything yourself. So actually, some of the commercial market is absolutely leading, and so you just want to go out and buy, and it might just be buying the data or it might be buying the service, but you've got to apply that lens to your way of thinking around how it is that you're going to procure capability, and I suspect that will therefore also help inform further down how you make the relative investments in the technologies and how that sort of feeds back through into academia and also industry.
So if we look to develop foundation models to make decisions for manoeuvres, collision avoidance, are there inherent risks around increasingly becoming more and more reliant on AI? How do we ensure that we kind of make sure our algorithms are secure, trustworthy? And perhaps, Elliot, you can give a view to the UK Space Agency's role on this.
Well, with any development of AI, you're automatically going to have an increase in your cyber attack surface and the amount of data you're going to be using. So for our role, we'll be looking at implementing cyber standards as early as possible into the development chain and ensuring that the companies and providers, they follow these. And one of the ways we do that is simply by going to small, medium enterprises and offering assistance in things like Cyber Essentials, which is what the NCSC recommends for all companies dealing with this.
So is the risk very different in a space setting from typical cyber attacks? So you're operating in a domain where you may not necessarily always be in contact with your asset. If somebody moves your asset, for example, it can be very hard to find it again. So are there additional things that we need to be thinking about, not just in terms of edge AI capability and how things change from an edge AI perspective, but from the fact that you are challenged in terms of when you can access your asset in the space domain?
I think in terms of edge AI, and you think about what edge AI actually means, putting AI models onto hardware that is in edge cases, limited in some respect. It's probably the extreme of edge AI, because once you put something onto a satellite and you put it into orbit, you're never going to touch it again. You're never going to be able to fix any hardware issues that come up. You're never even going to be able to examine it to see what might have gone wrong in the event of an issue. And you're putting it into a very challenging environment, a high radiation environment, so you get a lot of technical upsets with the electronics, that kind of thing. So there are a lot of challenges around deploying complex software onto satellites on orbit. There's a lot of hardening that needs to be done there. But absolutely, you're right. You also have very limited access to it from a software perspective. You can only upload and download limited amounts of data at a time, and only when you have line of sight between your ground station network and the satellite. And that might only be at certain times of the day for very short periods of time. So there are a lot of challenges around doing that. So I think there's an opportunity space there for developing the kind of models and the kind of hardware that can handle those types of challenges whilst operating on a very compact platform, and one that needs to be reliable for the entire duration of the mission.
We're seeing in the academic arena a trend towards looking at doing onboard automated capability, whether it be in the forms of detection, classification. Does the fact that you're trying to push machine learning algorithms closer to the edge also inherently raise the risk and threat level? And how can we go about mitigating against that?
Yeah, I mean, it's really interesting. I'm sure everyone's been tracking Manus, this new Chinese agentic system, which came out only probably 10 days ago or something. But I don't know if you've noticed this or played with it, but it's essentially a black box in terms of its agentic system. So you run the agents and you see them running and then you get the result. This is obviously a disaster for a space-based solution. You want to be able to understand what those agents are doing and let humans to make a decision. And so I think whatever we design, we need to find ways where humans can be in the loop and not just agents take control. The crazy thing is it's just so fast, right? These things, again, I really encourage you to look at Manus because, you can say, design me a website and a second later it's there. And so this is, the speed is changing, and this is, I think, something which might take us all by surprise, because it means that, essentially everything that we're building can be agentic. However, we need to be really careful because we want to make sure that human beings are involved in these extremely important decisions and create the opportunity for those decisions to be escalated as necessary, and then train those agents to know when they need to escalate. And this is all uncharted territory.
Is it realistic to always have a human in the loop in scenarios when it takes hours, or if you move even further away, even days to communicate with a platform that you want to be able to operate independently?
So, back to the question a second ago as well. I think there's always a danger that we try and design ourselves out. And that can be really quite dangerous. So there's a bit around also thinking about what we as humans bring to this, and that's largely expertise. And so trying to sort of design that in as something that's adding value is really, really important. So invariably what you've got to do is you've got to think about the sort of the end-to-end use case that you're looking at here, and think about that as a system, and try and identify, where do I need the human within this, and where is it that they are going to add most value to this as an overall process. So it's not we often think of this as a sort of binary in and out, and I don't think that's the right way of thinking about this. I think it's about, again, the sort of human-machine teaming that we've been talking about for some time. How is it we design ourselves into this to make sure that we're getting the most value out of the things that we do. We're great at, one of the things we were talking about earlier, things like resilience. That's one of the things that we as humans actually are really, really good at sort of dealing with when things start to fail, bringing things back into line, and knowing what's happened previously, and being able to apply past situations to this. So don't necessarily always think about designing us out. Think about where we design ourselves back in the best way that we can.
I think so. Sorry, you go.
I was going to say, jumping off of what Shaun was saying there about bringing in the human expertise where it's needed. If we envision for a moment a future SDA system that uses AI tools to track the tens of thousands, hundreds of thousands of objects on orbit, it is completely infeasible for humans to look at every single object every single day. We don't have the people to do that. Where an AI model could come in there is to look at the vast majority of objects that are behaving, the easy cases, the sensibly behaved objects that don't need a human to look at them that day. They take care of the vast majority of those, and then when something does behave, interestingly, when there's an event, when there's an anomaly, when there's a high-interest object that starts doing something, that's when the AI model can kind of take away the load of all of the easy stuff from the humans and flag up those anomalies to the human operator so they can spend their limited and valuable time looking at the interesting cases without wasting time on the vast majority of boring stuff, essentially.
Yeah, I mean, it's so interesting that, and we're sort of experimenting with this at the moment, and I saw something recently where people were designing agentic systems, and they used different base models for their agentic system, and OpenAI versus Gemini versus DeepSeek or whatever your base model is, and every agentic system was slightly different based on the LLM that was generating that. And I find that like an absolute box of frogs, because it means that ultimately we can't trust what we're building. And if you take that as a basic premise and say, listen, these things aren't trusted. Elon Musk said we'd have self-driving cars in 2015. Sure enough, we don't yet. Certainly not here in the UK. But I think the point is that getting to that last 2% or 1% of trust is really, really difficult. And so I really like the sort of thrust of this discussion is we're designing for humans right from the very beginning and making sure that humans have a chance, but also the systems know at the moment when they should be escalating.
Yeah, and just on that one, invariably you're going to find systems have boundaries, and those boundary conditions are going to vary because where defence is at and where we struggle with some of this is we operate within a complex operating environment. So if you're operating within a complex operating environment, then it's a system and it's going to have emergent properties. So ultimately those have not been seen before. So you do need the human within this to be able to support what it is that you're doing here, and it's really quite important.
And you need an AI model that can not only give you a confidence rating in its assessments, but can also put its hand up and say, I don't know about this one, and flag it to a human rather than just guessing. I think that's really important.
Yeah, and the training that needs to underpin that, that's not something that you can just sort of roll out and give to people, and they instantly go, well, that's fine. I've got it now. Don't worry. This is going to be fine. You've got to train with that. Soldiers and sailors and airmen, we've trained with things for years and years, and this is no different. You need to put that training in place, and that training needs to be comprehensive, and it needs to cover the spectrum of things that we find ourselves doing. Otherwise, you're going to set yourself up to fail.
How can we implement policy that ensures that we have more reliable AI algorithms when we implement them so that the user can trust in what they're using?
Well, invite scientists to be involved more. And again, foundation models are sort of fascinating because there's a sort of perception that if they're big enough, they're sort of, they know everything. But it turns out that really it's about the sampling decisions that were made as that foundation model is being built. In fact, sampling is more important than scale. And so some of the more recent foundation models that have been made for Earth systems, you can see where those prejudices have been built into the sampling strategy because, for example, they will fail in Antarctica because the people who are building them were saying, well, there's not many use cases in Antarctica, so we won't care about that. And it's those sorts of things which need scientists to check. And so there's a sort of absolute requirement for science as a sort of stepping stone in terms of making sure something is fit for purpose. But also, and this is really interesting, talking about the infrastructure for delivery of an AI service, the more it can be error checked in real time. So having a continual learning system means that it gets better and better through use, and that's what you need. But to do that, you need to have a always-on cloud infrastructure. You can't just have some GPUs that you spin up dynamically. You need to have an infrastructure which is much more similar to what GCP can deliver. And we just don't have those things here yet. Like we might have like a big supercomputer that you can use for a few days to train your model, but we certainly don't have an always-on infrastructure that allows you to create a continual learning system. And so these are the sorts of things we need to start thinking about. Sorry, slightly wrong answer to your question, but
yeah. So I would reflect on something that General Jack Shanahan said. I think this was back in about sort of 2019 when he was over at a sort of DSCL AI Fest, and he talks about getting AI off the bench because that's where again we've struggled. We tend to look at these things in lab-based environments where everything is set and it's very measurable. But ultimately, when we're sort of engaging with these things with users, the environment's not like that. And so you've got to take these things into naturalistic environments, and you've got to play with them in those environments and see how they respond, such that you can develop your techniques and your procedures in order to be able to deal and make these things work as effectively as you can. So that requires a bit of a change of thinking, both in terms of what is it we mean by assurance for these things, because you're getting into assurance with the user. The user needs to be part of that as you go forward, and it probably doesn't look like doing it in a laboratory. It probably looks like playing with this stuff for real. So we as users therefore need to come forward and be part of that as we go on that journey together. Otherwise, you're going to find that you're rolling things out, and it's not going to work in the way that you would wish it with us humans.
What do you think are the areas that the UK can really lead in this domain on? Are there certain areas that we are already ahead of the game that we should be developing?
I mean, I've sort of said already about AI for science. And we're really lucky that DeepMind has sort of positioned themselves as being, championing that idea. And I hope I'm not too prejudiced in this, but I believe that science is a crucial part of this, whether you're applying AI to healthcare or this situation, space situational awareness, space weather. There's a sort of temptation to think of them as engineering problems. But if you're trying to understand the relationship between the sun and the earth, that's a science problem. And so the more I think we can involve scientists, and the UK is great at science, arguably one of the best scientific countries on earth. And I think if we can celebrate that aspect and integrate more science and AI, that's just going to be, that's going to be the, if you like, the sharp point for our positioning.
I think to kind of rehash one of my previous points about developing these models with a scientific approach to do so, that can tackle a lot of these challenges in an autonomous way, but with the human in the loop. That is absolutely an opportunity for the AI community to kind of contribute to this space sector challenge. And absolutely, I think the UK has the expertise to do that. We need you guys to kind of acknowledge this problem and go, actually, this is a challenge that we want to tackle. And now we have the kind of, I think, the political will and the infrastructure to support that effort. We have commercially available and other available data sets, massive volumes of data for you guys to come and play with. And we have the infrastructure now to support the implementation and operationalization of those models as they come to fruition. So I think there's an opportunity now for that to happen and for the UK to be a lead on that kind of work.
It's, for me, I think what you're touching upon is it's the exploitation part of data. Getting the data and getting something that's useful to a user and connecting the scientific community who's good with all that kind of AI and processing stuff to in order to make those products is something that I think the UK can excel in.
I find there's a real drive in the UK to want to be part of the whole space economy and the space industry. And as was mentioned before, we have a fantastic pool of resource in the academia that we're producing, and talent pool that we've got, and space as a sector we've just seen grow exponentially bigger and bigger, and it's going to require more and more input to do that. So I think we can really lead the way in talent to solve some of these issues and challenges of AI and from AI.
I think now's a good point to start to bring in the audience a little bit. Have we got any questions in the room for the panel members?
Hello, thanks very much for a really interesting discussion. You mentioned a whole bunch of angles onto the sector, which is foundation models, agent-based models, always-on infrastructure, solutions that design in humans. And I wondered if you could comment a little bit more about who should be looking to play in this space. How do we collaborate across different types of organizations? So what's the role in government, public sector bodies? How do they collaborate with specialist space engineering companies that might perhaps own foundation models? What's the role of small consultancies? Where does academia play? Can we differentiate a little bit as to how we need to collaborate rather than compete across those industry verticals?
I mean, I can have a go in the foundation model thing. I mean, I think foundation models should be seen as public assets, that they, and the paradigm shift, which is we've been existing in, is like there's a spacecraft that creates data, that data is sitting in a silo somewhere, and then you might apply to use that, or it's public, like Copernicus. But generally, it's a world of pain to turn that data into something which is useful. In fact, it can take weeks. There's no reason why it should take weeks. I mean, it should take seconds. This is the power of foundation models. Really, is like getting all of those data sources. So, for example, everything we understand about the atmosphere, and putting this into one set of foundation models, which are maintained by a number of universities. Every time there's a new instrument, that foundation model is upgraded. This is a public asset that's used for lots and lots of downstream science. And I think that's the mindset that we should be moving towards. And it would be phenomenally useful for the UK if there was foundation models for omics and foundation models for weather and foundation models for the sun. Because if we had those things as public assets, the amount of science that could be done on the back of them would be enormous. It would be an explosion of possibility. And I'm imagining a future where all those autonomous devices, which we hope we'll build and we can rebuild a thriving economy on the back of, they're all accessing this public resource. And this shouldn't be run by one organization. These should be public assets. That's how I feel about it.
So the Alan Turing Institute is a founding member of the Institute on AI for Space Safety and Sustainability, and that's an international collaboration across the UK, Australia, Canada and the US, and it's got a combination of academic institutions involved, so MIT, University of Arizona, University of Strathclyde, University of Waterloo, with commercial organisations, so GMV, Nominal Systems, and also we work closely with the UKSA and government organisations, and as part of that we run a load of workshops. We also have training for those involved in the institute, and I think there's a role for organisations like the Alan Turing Institute as a convener, convening space for organisations as well.
I think aside from that, in particular, if you're looking to collaborate and get involved with work with government, work with defence, then there are a number of frameworks that we at DSTL and as part of wider MOD have that can allow academic and commercial kind of groups to come and work with us. Things like therapists, things like DASA calls, that kind of thing. So there's lots of ways for people to get involved and for us to kind of support that kind of work.
I guess from industry side, there's industry-supported accelerators and initiatives like that in order to kind of pull together SMEs and fix problems that customers could have.
Are there any more questions in the room?
Hi, thank you for the interesting talk. I'm just wondering what's actually being done on debris removal in space, and if that's still a thing that's sort of happening a lot, and what is actually viable.
So, I mean, I can talk about that. There is quite a bit of work on active debris removal in space. I think a couple of companies in the UK, such as Astroscale UK, are one of those. I can't quite see who asked the question. Other countries are obviously also involved in active debris removal. I think the UKSA has the UK ADR mission, COSMIC, which is a study going on right now, looking at using a robotic arm for this kind of stuff. So there's a lot of studies going on. I think the next step is actually doing this kind of experimentation in space.
From a feasibility aspect, there's not much we can properly do in terms of ADR at the moment. However, as was mentioned, the UK does want to be a leader in ADR missions, and there's a lot of funding and a lot of projects going on around ADR at the moment, especially in clear space and Astroscale. They've got a significant focus on getting that done and coming up with ways to do that.
I think just to add to that, there's also a much better culture now around sustainable use of space. So whereas in the 60s and 70s, satellites would go up into orbits that meant they wouldn't deorbit for decades. Nowadays, in order for objects to be licensed, they have to be put into an orbit where they will degrade naturally in a certain amount of time. I think it's 5 years, something like that. So even without any other intervention, your satellite will deorbit after 5 years just naturally through atmospheric drag. So there is definitely an angle of just using space more sustainably from the get-go and designing your space missions to be sustainable. However, unfortunately, the biggest challenge when it comes to space debris isn't those large single objects, the dead satellites, for example, that can be tracked and avoided relatively easily. It's the tiny objects. It's the objects that are between 1 and 10 centimeters that are very difficult to track with radar and telescopes and that kind of thing, but are still big enough and carry enough energy to have a devastating impact on anything they might collide with. Those are the real kind of challenges when it comes to debris, and it's really difficult to tackle that.
You got any more questions in the room?
Hi there. Thank you very much for the interesting talk. One of the problems that was shown to be the problem that's faced is being able to monitor the number of satellites when the number is too big for humans to look at. It seems to me that maps directly onto a similar problem faced in typical IT monitoring. When you have many, say, the tills that companies such as Under Armour have, they want to monitor their tills from a central hub. What are the challenges that I'm missing? What the satellites bring that don't allow this problem to be solved by a traditional IT monitoring system?
Typically, organisations wouldn't necessarily share information about where their satellite is, when they're going to manoeuvre their satellite. Perhaps you can come in on this.
Yeah, so there's a lot of different factors in play. So absolutely, as Victoria said, different nations operate their satellites in different ways. They have different licensing and policy decisions that have impacted how their missions are designed and operated. Often they will not necessarily share every piece of information that might be useful about their satellite. For example, if you launch a satellite and within a week it's dead because of some kind of technical upset, you might not necessarily publicize that for quite a while because you don't want to admit that you launched a satellite and it immediately failed. What that means is that from our perspective, we still assume that that satellite is alive and functional, and so that if you're operating your satellite and you have a conjunction event with this other satellite that you believe is alive, you might assume, oh, they're alive, they'll maneuver, I don't have to. But actually, if that's a dead satellite and you don't know it, then you need to be the one to maneuver because they can't. And so it's having that kind of information sharing that is very difficult because often people won't do that voluntarily. So I think we can tackle that with policy, but that can only apply to satellites that are licensed in the UK. Many of them are not. So developing tools that can, based on radar observations, optical observations, that kind of thing, infer and characterize objects on orbit, which is a step beyond just tracking them, is really important and quite a difficult challenge.
Yeah, I mean, it's also just having enough sensor data as well, and enough sensors to be able to, or sensors on task to be able to observe everything that is out there. The trajectories of these things, continually change, and so the data that you have on any one object will degrade over time. And invariably, there's a cost involved. If you're putting power into the atmosphere in order to be able to see something from a radar perspective, that's costing you in terms of time and money, and hence why a number of commercial suppliers have gone into that business and are supplying that data. It's really important that we all share that, but how does that work against the commercial model that exists for these companies?
Operating at the edge also means that you're very limited in terms of the amount of fuel that you may have on board. You might not want to be the one who has to manoeuvre if there are two in competition, deciding who should be the company or organisation that manoeuvres their asset that could result in having less fuel on board, that could reduce the life cycle of your mission.
There's a famous American astrophysicist called Marie Bejar. I don't know if people know him. He always calls them dead cameras. So basically, spacecraft that have lost their propellant, and they just, if you're in a collision course with one of them, you have to move.
I think that summarises an interesting space where perhaps the UK could really lead, and that's in those trade negotiations between organisations. I think, unfortunately, we're out of time, but I think you'll agree with me that we've had a very good panel today, so thank you ever so much to all of the panel members.
Thanks.